And you go. Your name, what you do?
I'm Andrew Daniels. I'm at Temple's electrical computer engineering department and computer science. Anyhow, so we're doing software-defined radio to map the spectral white space. This is the United States frequency allocation table. And it doesn't take into account space or time right now. So what we're doing is we're mapping the white space that's available, like all the dead spots for like cellular communications and all the other ones. There's a highly expensive real estate and valuable frequencies that are not being used. So we can map that space, and once we map it, we can give that as a recommendation to users that use the inherently finite frequency table, and in mapping that secondary, mapping that white space, we can make it valuable to secondary users. So we have a sensing part initially, and then we share, and then we can have separate transmission simultaneously if we do sense the spectral white space efficiently. So our application, we mine the spectral white space of we looked at FM radio as a test bed. So we have our daughter boards. This one receives, and this one receives as well. This one transmits our TX, our FM radio, and this transmits our data signal as well. So we have these together in a multiple input, multiple output configuration, or MIMO, and in doing so, we could communicate the spectrum data that we're collecting and transmit that and then store that in a database, which could then be accessed by people using the network.
What is the compression ratio? How much you can save in terms of bandwidth? Do you have any value?
Historically, they used very inefficient modulation techniques to store data. So, like that's FM radio. It takes a huge span, and these are that's TV basically. And that takes a huge span as well, but they're valuable frequencies that can transmit large amounts of data. And they're
so with
being
this
used
algorithm,
inefficiently with
it will be all blue, yes?
Yeah.
With all blue.
The
Dynamic control.
Yeah, and those are owned by corporations and things, but they're using outdated technologies in storing their data in the signal.
Yeah, the industry is still not this. The industry is still pretty loose.
Well, yeah, we can use 4G communications in order to fill the white space. So we can have tremendous gains in the amount of available bandwidth. Using what's not used currently and without interfering with anything.
So you're the PhD student?
Yes.
You're leading the project?
Yes.
You're leading the project. This is your dissertation topic?
No, this is a part of it. This is
part
our
of the thing.
Future phase. Because right now we have published like several papers on those test beds, based on those test beds, and this is our next phase to build a recommendation system, which is gonna recommend user like which spectrum right now is the best quality for you to communicate. So we're using the collected data by the USRPs, and then we apply data algorithms to find the association rules between the time dimension, location, frequency, and the availabilities. So in that way, based on our recommendation systems, when user enters some area, it doesn't limit it to 3G network or Wi-Fi network. Basically, every spectrum is available, and we're gonna recommend which one may be the best for you, like recommendation based system.
So we can have high throughput in a local area using a wide range of frequencies without interfering with anyone else's use of them.
Thank you.
So we